Okay, so number one, which function graph has a period of 8 and reaches a maximum height of 1, if at least one full period is graphed? All right, now, in order to deal with this, the period of 8, you can use either one of the two formulas, period equals 2 pi over frequency, or I'm going to use, I think it's actually easier to use frequency equals 2 pi over the period. The reason I think this one's easier to use is because they give us the period. So I'm going to replace the period with 8. And if I simplify this, 2 over 8 simplifies to 1/4. So this would be 1 pi over 4. Okay, so we can automatically eliminate choice 3 and 4 because the frequency is what goes in front of the x, and these have frequencies of 8, so it can't be either one of these. Okay, these are the two that have a frequency of pi over 4. Now here it says I crossed it off, I meant to underline it, but the maximum height is 1. So we know the formula for max is vertical shift plus the amp. So what are the two answer choices we're taking a look at? Let's just go through them and let's see which one works. So in choice 1, your vertical shift is -3, and then plus the amplitude. Well, even though this is a negative in front of the function, the amplitude is just 4. Okay, amplitude has to be a positive number, so the amplitude is 4. So -3 plus 4 is +1, so actually that fits this. So choice 1 is the answer. The reason why it's not choice 2 is because if we did vertical shift plus the amp, we would have 5 plus 4, which is 9. So choice 2 isn't going to work. So number 2 gives us this equation, the half-life of iodine-131, and it tells us that it can be rewritten in the equivalent form like this. Okay, so when they want us to know what is the approximate value of k. All right, well, there's a couple different ways you can go about doing this. So, I mean, what I thought was easy is just look at both of these expressions. They both have 100 in the beginning, and they both have a d up in the exponent spot. So let's try to get this d by itself as an exponent on the outside of parentheses, and let's see what happens. So let me show you what I mean. All right, let's start with this first one. We could see here that this is really 1d over 8, so you can rewrite this as 1/8 d for your exponent. Okay, so just like that. So what I did was I just took the 1/8 and brought it in front of the d. Now we know if we have an exponent, we can move it to the inside of the parentheses as an exponent, and it doesn't change the value of the expression. So I'm just going to take this 1/8, and I'm going to bring it to the inside of the parentheses. Okay, so I just took this and shifted it in. So now I have the d all by itself. Now I'm just going to plug this 1/2 to the 1/8 power in my calculator, and keep in mind, you're not multiplying these. This is 1/2 raised to the 1/8 power. Okay, so I had to, round when I plugged this in my calculator because this decimal would keep going, but I just rounded it to 0.9170. All right, now let's take a look at this right here. I have 100 in front of my parentheses and a d as my exponent on the outside of the parentheses. If we just take parentheses and insert it right here, you'll see I have 100 in the front of the parentheses, just like I do here, and I have a d as my exponent on the outside of the parentheses, just like I do here. So since these two expressions are equal to each other, if I just take what's in my parentheses and set it equal to what's in the parentheses here, I can now solve for k. Okay, again, so we're going to just take this and set it equal to this. Okay, that's what I did here. All right, so now solving for k should be pretty easy. I mean, if we have an e in our in our equation, we can just put ln in front of both sides of the equation, because we know that ln of e to the k power is just equal to k, right? Basically, these two just cancel each other out, and we could bring down the k. And then you would just plug this into your calculator and see what you get. So it looks like we get -0.087. Okay, so that would be choice 1. Okay, number 3, since it's multiple choice, a really easy way to do it is, as long as x is not stored as 0, -1, or 1. I mean, might work out, but I would just plug this entire thing, this entire expression into my calculator, hit enter, and plug in these expressions one by one and hit enter, and see what matches up. And to be honest, that's a really good way to check. Even if you do this by hand, that's always, you know, your calculator is always really good way to check. All right, but I'm going to do it by hand, because this could easily be a part 2 where you'd have to show work. Okay, so the first thing I did here was, since these had squares on it, I just wrote them out twice. All right, and that way now what we can do is we can double distribute. So x times x is x squared. X times 3i would be 3xi. 3i times x would again be 3xi. And then 3i times 3i would be 9i squared. Okay, now before I double distribute here, right, I'll work with that in a minute. Let me just combine my like terms and see what we could do here. Now first thing, we know that I squared is equal to -1. So 9 times, I'm just going to cross this off and make this a -1. So 9 times -1 is just -9. Okay, so this becomes -9. Now I'm just going to take my x squared here and bring it down. And I can combine these because these are like terms. So 3xi plus 3xi would be 6xi. Okay, so now let me go to this over here. Now, I'm going to double distribute, but because we have a minus sign here, I'm going to keep it, whatever I get, I'm going to keep it in a parenthesis, because we're eventually going to have to distribute this negative to everything within the parentheses. All right, so let's double distribute. So 2x times 2x is 4x squared. 2x times -3i would be -6xi. Okay, -3i times positive 2x would be -6xi. And then -3i times -3i is positive 9i squared. And again, we know that I squared is equal to -1. So when we multiply 9 times -1, this is going to wind up coming down as a -9. Okay, so let me bring everything else down. I'm going to bring down the minus sign. I don't want to forget about that parenthesis. I'll bring down the 4x squared, and then I can combine these two middle terms to give me -12xi. Okay, so I'm going to bring down x squared plus 6xi minus 9, and now I'm going to distribute this negative to all three terms. Okay, so let's start here. Negative times 4x squared is just -4x squared. Negative times -12xi is positive 12xi. So basically all the signs within the parentheses are changing. So then negative times negative is positive, so we wind up with a positive 9 at the end. And from here, just combine your like terms. Alright, so we can combine x squared minus 4x squared to give us -3x squared. 6xi plus 12xi would be positive 18xi. And then actually what happens is the -9 and the positive 9 just cancel off. Okay, so it looks like that would be answer choice 3. But again, just to double check your work, I would always plug the original expression in your calculator and hit enter, and then plug your answer choice in the calculator and hit enter, and make sure those two values match. Alright, so number 4 tells us what p of x is equal to, and it tells us what m of x is equal to, and it wants to know when does p of x equal m of x. Alright, okay, so what they're looking for you to do here is to take what p of x is equal to and plug it into y1 in the calculator, and then you're going to take what m of x is equal to and plug it into y2 in the calculator, and we just want to look, when it's phrased like this, we're looking for the x value where they intersect. Because think about it, if you took what p of x was equal to and set that equal to what m of x is equal to, don't we only have x's in our equation? So here, we're looking for the x value of their point of intersection. Okay, so here we go. P of x is in y1, m of x is in y2, and then I just went to second trace intersect. I had to move the cursor over a little bit to get on the curve, and then when I hit enter, 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 it gave me this as the point of intersection. Okay, so again, we're looking for the x value, so this would be choice 3, 5.62. All right, so number 5 wants to know which equation represents an odd function. Now, we know that an odd function means that it's symmetric about the origin. So if you rotate it 180 degrees, it's going to look exactly the same. All right, so I would just go through and graph each of these one by one and, figure out which one is odd. Okay, so what I did here, I just graphed them in the calculator one by one. So if you look at this first one, y equals sine of x, this is the one that's odd. I'm going to actually try to do this. If you take this and rotate it 180 degrees, see, we know sine, it increases as it goes through the origin, and it follows the same pattern over and over again. But if you took this, and let's see if I could do it here, flipped it, rotated it 180 degrees, yeah, what you'll see is, look at this. It's the same exact curve, right? It's increasing as it goes to the origin, and it's doing the same thing over and over again. If you rotated any one of these three 180 degrees, it wouldn't look the same. Like, see how cosine of x right here is, it's up at 0, positive 1? If I were to rotate this 180 degrees, look at this, it would be down at 0, it'd be at 0, negative 1 down here. So this one's actually symmetric to the x-axis. If you fold along the x-axis, this left-hand side of the graph will fit directly on top of the right-hand side of the graph. We call that even. Okay, this one's neither, and this one's neither. Okay, so number 6. On average, college seniors graduating in 2012 could compute their growing student loan debt using this function that's given to us right here, where t is the time in years. Which expression is equivalent to this? So which expression is equivalent to the right-hand side of this equation and could be used by students to identify an approximately daily interest rate on their loans? All right, well, a really easy way to do this, I mean, since it's multiple choice and they want to know which could be equivalent, is just plug in a number for t right here, and then plug in that same number for t into each of the answer choices, and see which one is equal. So you could plug this in your calculator, right? Take t and replace it with a 2, and plug that in your calculator, and then replace each of these with a 2 into your calculator, and see which one is equal. Okay, but I'm going to do it by hand. So if you want to convert from time in years to a different time period. So this one's asking us to find the daily interest rate. So we're really converting from years to days. What we do is we stick a number in front of the t in our formula. See, this is the same formula as this, except we're sticking a number in front of the t. And then to compensate for doing that, we put its reciprocal, 1 over n, as an exponent inside the parentheses. So n stands for the number of days that fit in a year. Okay, so what that means is n has to be 365. There's 365 days in a year. So you're just going to replace this n right here, I'm just going to cross it off, with a 365. And then to compensate for doing that, we're going to replace this n right here with a 365. Okay, so just look for what answer choice says that. So it looks like choice 4 right here, okay? So choice 4 is our answer. Okay, now with choice 7, I will do this one out by hand just so we can, practice in case it's a show your work. But if it's a multiple choice, I do not recommend doing this by hand. I recommend just taking the answer choices and substituting them in for the x into the equation just to see which one checks out. Okay, so for choice 1, it gives us 5. So we're going to take 5 and substitute it in for all the x's. Okay, and we're going to see if the left-hand side of the equation equals the right-hand side of the equation. Okay, so when we plug in a 5 and for x into both sides of the equation, on this side we get 5 squared is 25, and then 4 times 5 is 20. So 25 minus 20 is 5, and then if we subtract 5 from that, that gives us 0. So on this side of the equation, we get the square root of 0, which is just 0. Okay, now on the right-hand side of the equation, 2 times 5 is 10, and 10 minus 10 is 0. So we get, when we substitute 5 in for the answer choices, we get both sides of the equation to check out. So we know right away it can't be answer choice 2, because 5 has to be in our answer, so it can't be this one. Okay, but all of these other answer choices contain a 5, so it could be any of these. All right, so let's try, with choice 3, let's plug in the 7, because if 5 and 7 check, this could be an answer. So let's see what happens when we substitute 7 in for x. Okay, so if we do 49 minus 28 minus 5, that gives us 16. So we get the square root of 16, and we know the square root of 16 is 4. Okay, now let's see the other side of the equation. 2 times 7 is 14, and 14 minus 10 is 4. So if we bring down the 4, we'll see that both of these check. Okay, so at this point, since 7 also checks, we realize choice 1 can't be the answer. So it could be either choice 3 or choice 4. Now the only difference between them is choice 4 contains a 3, so let's substitute 3 in and see what happens. Okay, so when we do that, 9 minus 12 is negative 3, and negative 3 minus 5 is negative 8. So we get the square root of negative 8, which I'll worry about simplifying that in a minute. Let's just worry about the other side of the equation. Now let's think about this. Here, these can't be equal to each other because 2 times 3 is 6, and 6 minus 10 is negative 4. Okay? If we have a negative under the radical, we know that's going to give us an imaginary unit, right? It's going to give us an I in our answer. So these cannot be equivalent. So I'm not even going to take it any further. I'm just going to say these aren't equal. So since 3 is not a part of our solution set, choice 4 also is not the answer. So choice 3 is the answer. Now I'm going to do this by hand as well, just so you can see how to do it if it's a part 2. Okay, so when solving a radical equation, the first thing you want to do is you want to get the radical all by itself on one side of the equation, which it already is. So when we have that, we can just square both sides of the equation. So I'm going to square the left, and I have to put the right-hand side in parentheses to show I'm squaring it, so I'm squaring the whole thing. Okay, so what happens is a square and a square root cancel each other out, so I could just bring down the x squared minus 4x minus 5, and on the right-hand side, since this is being squared, it means we have 2 of them, so let's write it out twice. That way we can double distribute, right? Don't just try to distribute this in. That's not going to give us the right answer. Okay, so I'm going to just bring the left-hand side down, and when we double distribute, we get 4x squared minus 20x minus 20x plus 100. All right, so we know we're going to have to combine our like terms as well as bring everything to one side of the equation. So let's just do it all at once. I'm going to bring everything to the right-hand side of the equation because 4x squared is bigger than 1x squared, and I want my leading coefficient to be positive. So I'm going to just subtract this x squared from both sides. I'm going to add the 4x to both sides. And I'm going to add the 5 to both sides. Okay, so on the left-hand side, at least, we have 0. And on the right-hand side, 4x squared minus x squared would be 3x squared. And then negative 20x, and positive 4x would combine to give me negative 36x. And then here, 100 plus 5 is 105. Oh, and what's nice is everything here is divisible by 3. So to make my life easier, I'm just going to divide both sides of the equation by 3. So that leaves me with 0 equals x squared minus 12x plus 35. Okay, I just divided each of these by 3. And from here, it's just a pretty straightforward factoring problem. Set up 2 sets of parentheses, and put an x and an x, and come up with 2 numbers that add to negative 12 and multiply to positive 35. So negative 5 and positive 7. And then we're going to make a t-chart and solve. Now, I don't know why I wrote positive 7. I'm sorry, that was wrong. That should be negative 7. So we get x equals 5 and x equals 7. And we already did the checks in the beginning of the problem. But, at this point, normally what you would do is check. And you would see that the 5 checks as well as the 7. So they're both our answers, so choice 3 is the answer. Okay, when you read number 8, it wants you to completely factor this given expression. Now, some of you may look at this and say, you know what, I'm just going to take this and plug it into my calculator and hit enter. And then let's plug in the answer choices and plug those into the calculator and hit enter and see which one matches up. Okay, so what I did here was I just took a little screenshot of when I plugged this into the calculator, I just plugged it in using x's. I think x was stored as 10 in my calculator. It doesn't matter what it's stored as, but this is what I got. Now I went through and typed in each answer choice, like here's choice 1. And look, that matches up, okay? This is the same value as the question. Choice 2, you could see when I plugged, this into my calculator, it didn't match up, so choice 2 is not the answer. Choice 3, look, this one matched up too. And then choice 4, you could see it didn't give me the same answer choice. So 2 of these actually checked out. So you have to kind of look and say, well, which one is completely factored? Well, if you look at choice 1, see this in here? This is dots. This factors further to d plus 3, d minus 3. So choice 1, this is not completely factored. So that means choice 3 would have to be our answer. So if you're doing it in the calculator, don't just plug in the first one and say, oh, look, that matches up. That must be my answer. Make sure you go through and plug in each answer choice one by one, because if more than one answer checks out, you have to, logically think about which one would be correct. Okay, I'm going to do this one by hand now, though. Okay, so if we were to do this by hand, we see 4 terms, so I'm thinking we're going to have to use grouping. But before we do, let's look and see, is there anything that divides evenly into all 4 terms? Well, if we look at the numbers, 2 divides evenly into all of them. And then in addition, look at this, they all contain at least a d, so we can pull a d out of each of these terms. Okay, you always look at what has the smallest exponent out of these, so 4, 3, 2, 1, d to the first, and that's how you decide how many to pull out. Okay, so let's see what we're left with. So if we had 2d to the 4th and we pulled out a 2d, well, we had a 2 and we pulled it out, and we had 4 d's and we took one of them out, so we still have 3 of them, so we could rewrite that as d cubed. And then plus, so when you're factoring something out, you're really dividing. You're saying 6 divided by 2 is 3. And if I had 3 d's and I took out 1, I still have 2 d's, so d squared. All right, so let's keep going. So then negative 18 divided by 2 is negative 9. And I had 2 d's, but I took one out, so it still leaves me with a d. And then negative 54 divided by positive 2 would be negative 27. And I'm going to close up the parentheses, because although I had a d, I took it out. Okay, so let's continue on. So I'm going to bring the 2d down. And now this is where I'm going to do grouping. I'm going to group together my first 2 terms and group together the second 2 terms. Okay, so here I want to say, well, what can I pull out of these 2 terms? What do they have in common? Well, they don't have any numbers we could pull out, but we could pull out d squared, right? Again, look at which one has the smallest exponent. This one does. So we could pull out a d squared. And if we do in parentheses, that leaves us with d plus 3. Okay, now if we look at these next 2 terms, you could either pull out a positive 9 or a negative 9. But think about it. If you want to be left with a positive d and a positive 3, in parentheses, if we want to be left with positives, then we got to pull that negative out. So let's pull out a negative 9. And then negative 9d divided by negative 9 is positive d. And negative 27 divided by negative 9 is positive 3. Then we can close up the parentheses as well as closing up this parenthesis right here. And if you notice, look, the d plus 3's match. That's what we wanted to happen. That should happen when you're doing factor by grouping. Okay, so now let's bring the 2d down. And we're going to take this d squared and this negative 9 and combine them together in one parenthesis. And then we're going to take this d plus 3 and we're writing it just once. Okay, now if you remember when we did it, using the calculator method, this right here matches up with choice 1. So they were trying to trick us. That is not completely factored. That's, partially factored. It's almost there, but not quite there. So this d squared minus 9 is dots. It factors further. So we can factor that to d plus 3 times d minus 3. And just bring everything else down. So you could bring down the 2d, and you could bring down the d plus 3. So this is now completely factored, and we want to see which answer choice matches up with this. Well, if you look at choice 3, see how they wrote d plus 3 squared? That's exactly what we have here. We have 2 of them, so we could write that as d plus 3 squared. And then we have our 2d, and we have our d minus 3. So choice 3 is the answer. Okay, number 9, which diagram shows an angle rotation of 1 radian on the unit circle? All right, well, first of all, when we work our way around the unit circle, we usually, do it in terms of degrees, right? From here to here would be 90 degrees, and this brings us to 180, 270, and all the way back around to 360. So the first thing we're going to want to do is we're going to want to take this radian and convert it to degrees. So we have 1 radian. Now, to convert from radians to degrees, what we do is we multiply by 180 over pi. So, I would just plug this in your calculator. 1 times 180 over pi. And when you do, you see it gives you approximately 57 degrees. So 57 degrees would be in the first quadrant, right? It would be between 0 and 90. So it looks like choice 1 would be our answer, right? This looks like it's opening about 57 degrees. This one's opening 90, this one's opening 180, and this one's opening 360. So choice 1 would be our answer. Okay, so number 10 wants to know which function is even. So as you can see here, I just went through and I graphed each of these in the calculator one by one. And if a function is even, it means it's symmetric about the y-axis. So if you were to fold along the y-axis, one half of the graph would fold directly on top of the other half of the graph. If you look at this right here, choice 1, it says y equals sine of x. This is not even. If you were to fold along the y-axis, this bump up here would fall up here above the x-axis, which it's not. So choice 1 is not even. Choice 1 is actually odd. Odd means if you rotate your paper, or you rotate your graph 180 degrees, it'll look exactly the same. If you do that with choice 1, if you take this and just take it and just rotate it 180 degrees, this graph will look exactly the same. Okay, choice 2, if I were to fold along the y-axis, this is our answer. This is the one that's even. This right-hand side of the graph would fall directly on top of the left-hand side of the graph. So choice 2 is our answer. Okay, number 11, it gives us this situation and it gives us this equation. But basically what they want us to do is they want us to solve for j. And when they say in terms of f and w, what that means is there'll be an f and a w in your answer. Okay, so they want to know j equals what? So we're going to solve for j. Okay, so we have to find a common denominator. Now, since this one contains a j, this one contains a w, and this one contains an f, let's just make our common denominator jwf. All right, so this has the j, it's missing the w and the f, so what we're going to do is we're going to multiply the top and bottom of this fraction by wf. The denominator in the middle here has the w, but it's missing the j and the f, so let's multiply top and bottom of this fraction by jf. It doesn't matter what order they're in, as long as they all have a j, as long as all the denominators have a j, a w, and an f. Okay, and then the last fraction here, the denominator has the f, but it's missing the j and the w, so we'll multiply top and bottom of that fraction by jw. Okay, so now all the denominators have a j, a w, and an f. Okay, so now that we have a common denominator, we can cross off the denominators, and we're just going to solve the equation of what we're left with in the numerators here. So wf times 1 would be wf, and then I'll bring down this addition sign, and this says jf times 1, so that'll be jf. I'll bring down the equal sign, and this one says jw times 1, so that's jw. Alright, so if we remember, what we need to do is we want to solve for j. So if we want to solve for j, we have a j here and a j here. We need to get them on the same side of the equation. Alright, so I'm going to move actually this term to the right-hand side of the equation, just so that I don't have to worry about moving this too. So I'm just going to subtract jf from both sides of the equation. So when I do, on the left I'm left with wf, and on the right, these are not like terms because this says jw and this says jf. In order for them to be like terms, they'd have to have the same exact variables. So I'm just going to leave that as is, as jw minus jf. Okay, so now this is the tricky part. What we need to do is we're trying to get the j out of both of these two terms. Now, some of you may be thinking, oh, let me divide both sides of the equation by j, and you'll get rid of it from both of these terms. But then you're bringing a j back on this side of the equation, so that's not really going to help us out too much. I mean, could you solve it from there? Yes. But the easiest way to get the j out of both of these two terms is just to factor it out. Okay, so let's do that. I'm going to factor out a j, and when I do, in parentheses, I'm going to be left with w minus f. Okay, so again, what I did on the right-hand side was I wanted to take the j out of both these two terms, so I factored it out. When I factor a j out of this term, it leaves me with a w, and then I bring down my minus sign. When I factor a j out of these terms, it leaves me with an f. Okay, and then I can bring down my wf on the left-hand side, and then to get j by itself, just divide both sides by w minus f. Okay, so that leaves me with j equals wf over w minus f. Now, if we look at choice 3, it says fw over w minus f, okay? When you're multiplying, it doesn't matter what order you multiply in, you still get the same answer. And honestly, they just took them and wrote them alphabetically. Okay, so that actually makes more sense than how I wrote it here. So this answer matches up with choice 3. Okay, in number 12, they give us a recursive sequence, right? They tell us the first term equals 6, and to determine the nth term, just multiply the previous term, right? A sub n minus 1 means the previous term, times 3. So what they're showing us here is this is geometric, right? Because we're multiplying the previous term by 3. And they want to know how else can this be written. Now, my first thought would be to take, this sequence and write the explicit formula. Now, since it's geometric, we know that the explicit formula would be a sub n equals the first term times r to the n minus 1 power. So a sub n would be equal to the first term, which they tell us right here is 6, times r. So that means what are we multiplying by to get from one term to the next? Right here, 3 to the n minus 1 power. Now, if we look at our answer choices, this answer choice is not here. There's things that kind of look like it, but that's not exactly there. So now we got to come up with a plan B. Now, I honestly think the easiest way to do this question, think about it. If they're telling us a sub 1 equals 6, what that means is the first term equals 6. If we replace n in each of the answer choices with a 1, when n equals 1, the value of that expression should equal 6. Okay, so let's try this out. Okay, so in choice 1, if I replace the n's with 1's, I get a sub 1 equals 6 times 3 to the first. Well, 6 times 3 to the first is 18, okay, not 6. We're looking to get 6 here, so choice 1 isn't the answer. Okay, choice 2. If we take the n's and replace them with 1's, we'll wind up with a sub 1 equals 6 times 3 to the 1 plus 1. Well, 1 plus 1 is 2, 3 squared is 9, and 6 times 9 is 54. So that's not our answer. We're trying to get, when we substitute the 1, we're trying to get this expression to be equivalent to 6. Okay, when we replace the n's with 1's in choice 3, we wind up with a sub 1 equals 2 times 3 to the first, which that is equal to 6. So this is most likely our answer, but don't rule out choice 4. You got to try out all of them, because if more than one of them give you 6, then we'll have to figure out what the second term is and see which one makes sense with the sequence. Okay, choice 4, when we substitute the n's with 1's, we get 2 times 3 to the second power. So 3 squared is 9, and 2 times 9 is 18. So choice 4 doesn't work, so it looks like choice 3 is our answer. Number 13, on a given school day, the probability that Nick oversleeps is 48%. So I wrote the probability of oversleeping is 0.48. And the probability that he has a pop quiz is 25%. So I just put probability of quiz is 0.25. All right, assuming these two events are independent. Now that's really important, because if you remember our rule for independence, two events are independent if the probability of oversleeping and having a pop quiz is equal to the product of their individual probabilities. So the probability of oversleeping times the probability of having a pop quiz. All right, so since they're independent, all we really have to do is just multiply the probability of oversleeping and the probability of having a pop quiz. So this would be equal to 0.12, which is 12%, choice 4. Okay, so number 14, you can do this in your calculator if you want. You can just plug the question in and hit enter, and plug in the answer choices one by one and hit enter and see what matches. Just make sure that your x and your y aren't stored as like 0 or even 1. You know, that can mess you up. So I'm going to store my x as 2 and my y as 3. Okay, and now let me plug the original expression into the calculator. Okay, and this is what I got. I wound up getting 0 as my answer. I may want to either store my x and y as different values, and you could be unique. You could be like 2.643, and you know, whatever you want. Or I can plug in the answer choices one by one, and let's, fingers crossed, hopefully only one of them gives me 0. Okay, I decided to go with the first option because I didn't want to take the chance of, you know, plugging all those in and getting more than one of them to equal 0 because it's a lot to type in when you look at that. All right, so I just changed my values. I stored x as a unique number and y as a unique number, and then when I plugged in this original expression, I got a very unique answer. Okay, now let me plug in the answer choices one by one, and hopefully only one of them gives me this unique answer. Okay, so I took the time to type these in one by one, and don't be tricked. Number 1 kind of looks similar, right? It ends in the 0.616, but the numbers are different here. Choice 4 is the one that matches up perfectly, so choice 4 is going to be our answer. Okay, I'm also going to do this by hand because you don't always want to just rely on the calculator. Okay, so what they were looking for you to see here is, if you notice, since this parenthesis and this parenthesis say the same exact thing, this is the intermediate step of factor by grouping. Okay, they wanted you to realize that you can take what's on the outside of these parentheses and group them together within one parenthesis. So the x to the 6, y to the 4th, we can group with the minus 9, and then this common binomial factor here, we can rewrite, and when we do, we just rewrite it once. Okay, and then from here, let's just factor further. Now, both of these are difference of perfect squares, because everything up here is a perfect square. Okay, if a variable has an even exponent, it's a perfect square, and we know all of our perfect square numbers. All right, so I'm going to factor this first parenthesis further. I'm going to set up 2 sets of parentheses, and the square root of x to the 6 is x cubed, and the square root of y to the 4th is y squared. Okay, all you really do is just take those parentheses and cut them in half. So x cubed, y squared. And then we're going to make 1 plus and 1 minus, and the square root of 9 is 3. So we'll make this a 3 and this a 3. All right, now if we look at this, we could say this is also a difference of perfect squares. So let's set up 2 sets of parentheses. Okay, we're going to have 1 plus and 1 minus, and the square root of x to the 4th is x squared, and the square root of 16 is 4. Okay, now since these are binomials, really, other than factoring out a GCF, which we can't do, the only way you could factor further is if we have a difference of 2 squares. Now these two have addition signs, so we can't factor that further. This has a difference, but x cubed is not a perfect square, and 3 isn't a perfect square. So the first 3 sets of parentheses I'm just going to bring right down. Okay, this last parenthesis here, though, this is another difference of 2 squares. So you can factor that further to x plus 2 times x minus 2. Now, here's the thing. If you go back and look at the answer choices, the answer choice didn't factor completely. It actually, if you look for this answer choice is not there. It left it at this step right here before the x squared minus 4 was factored. So this, they just said which is equivalent. They didn't say which is factored completely. So this is equivalent to this. And to be honest, I found this one so much faster to do by hand than I did, you know, using the calculator cheat method. Number 15, the weights of bags of Grade 6 chocolate candies are normally distributed with a mean of 4.3 ounces, underline that, that's important, and a standard deviation of 0.05 ounces. What is the probability that a bag of these chocolate candies weighs less than 4.27 ounces? Okay, so they're looking for us to do normal CDF here. So when we do normal CDF, we're going to do that in our calculator, and the first thing we want to do is we want to tell it what we want our lower bound to be and then what we want our upper bound to be. So if we want them to weigh less than 4.27 ounces, 4.27 is going to be our upper bound, and then we want to look at everything less than that. Now, normally we use for a lower bound a really small number, so like -9999, but honestly, you could use 0 instead, because it's not like something is going to weigh less than 0 ounces anyway. So if you use 0 here, you'll get the same answer. That'll be perfect. And so we're going from a really, really low weight up until a maximum of 4.27. So that's going to be our upper bound. And then after that, we put the mean and then the standard deviation. Okay, if you forget where to go in your calculator, you know, in order to do this, you would go in your calculator over to second and then distribution, second vars. Okay, it says distribution above that, it's right next to the clear button, and you're going to choose choice 2, and you'll see normal CDF. Okay, so I'm plugging this in my calculator, and when I do, I wind up getting 0.2743. So that's going to be choice 2. Okay, number 16. A manufacturing plant produces 2 different size containers of peanuts. One container weighs X ounces, and the other weighs Y pounds. All right, so we're using different units here. We're using ounces and pounds. All right, if a gift set can hold 1 container of each size, which expression represents the number of gift sets needed to hold 124 ounces? Okay, so I'm going to right away rule out choices 2 and 4. And the reason I say that is because if we have 124 ounces, and we want to divide that by the number of gift sets needed. Okay, we want to figure out how many gift sets do we need if we can hold all together 124 ounces. So we're going to do the 124 ounces and divide it by the number of gift sets needed. So we're, 124 has to go on the top, okay? We're dividing that by the gift sets. All right, well, let's think about it. So it tells us that a gift set can hold 1 container of each size. So it can hold a container of X ounces and a container of Y pounds. Now, because these are in different units, we're going to need to convert them to the same units. That way we can figure out what we're going to need to divide the 124 by. Now, if you don't know offhand, this is actually given to you on the reference sheet. Okay, so 16 ounces is equal to 1 pound. Now, because this 124 in our numerator is in ounces, we're going to want to convert the one that's in pounds to ounces. So it's actually pretty easy to do. If you want to convert from pounds to ounces, since there's 16 ounces in 1 pound, just take pounds and multiply it by 16, and that'll convert it to ounces. So if we take Y pounds and multiply that by 16, right, 16 times Y is just 16Y. So this would be 16Y ounces. And this is already in terms of ounces, right? X ounces. So really, the gift set will contain X ounces plus 16Y ounces. So if we want to figure out how many gift sets we can contain, you would take the 124 and divide it by X plus 16Y, which is what choice 3 says. That was a tricky one. Okay, so in number 17, they tell us that the number of white-winged crossbills can be represented by this formula, and it says that T is the number of years since 2010. Now, what they want us to do is they want us to take this and they want us to convert it to monthly growth rate. All right, so this is the formula we're going to use. We're going to basically just take this equation, and we're going to put the number of months in a year in front of the t, and to compensate for inserting a number there, we're going to put its reciprocal on the inside. So we know that there are 12 months in a year, so this is going to tell us that n equals 12. So really all we're going to do is we're going to take the n's in this formula, and we're going to replace them with 12s. Okay, now from here you can just take what's in the parentheses and you can plug that into your calculator, and when you do, you see you get about 1.00643, and then I'm just going to bring down my exponent of 12t. So that would be choice 2. Now, if you ever have trouble with these, if you're not really sure, I know some of you guys, have told me in the past that you have trouble trying to figure out which one it is. I mean, the easiest way to get around it with multiple choice is just plug in a number for t right here. So let's say you want to plug in, I would plug in a low number just so that the answers aren't like outrageous, but I would maybe substitute that with a 2, right? And plug it in your calculator, and then substitute 2 in for t into each of the answer choices, and see which one gives you, it's not going to give you exactly this value, because remember, this is a rounded decimal, but see which one gives you the closest to what your calculator gives you right here. Okay, so here's what I mean. I took the original, just the right-hand side of the equation. So I took this expression and replaced the t with a 2, and this is what I got in my calculator. Then I took each of the answer choices. So here's the first one. I substituted this t with a 2, and this is what I got. Okay, I took the second answer choice, and I replaced this t with a 2, and this is what I got. And if you look at all the answer choices, this is 641.52. I mean, this isn't exactly, because remember, this decimal in here is rounded, but this is 641.46. So this is as close as you're going to get to that, so choice 2 is the answer. All right, number 18, I mean, it's multiple choice. If you want to figure out what value of x is the solution to this equation, you can just take these answer choices and plug them in one by one for x, and plug it in your calculator and see which one is closest to this. But I'm just going to do it by hand. Okay, so if we want to solve this equation, the first thing we're going to do is we want to get the e by itself. So I'm going to divide both sides by 87. All right, so that gives me e to the 0.3x equals, and I'm just going to leave this as a fraction because then there's no rounding involved, okay? That's an exact value. Now we know to get rid of an e, what we do is we put an ln in front of both sides of the equation. Just going to put that in a parenthesis so we see we're taking ln of that entire fraction. And what happens is the ln and the e cancel each other off when we bring down the 0.3x, and I'm going to leave this as ln of that fraction. And then just to finish solving, just divide both sides by the number in front of the x. And you're just going to, like, literally just plug this in your calculator and see what you get. So we wind up getting, I'm just going to round it to what the answer choice does, 14.066, choice 4. Okay, so number 19 can be done by hand, or you can use the calculator cheat method. I'll show you the calculator cheat method first, and then we'll do it by hand. Okay, so with the calculator cheat method, the only thing I would do is I would just make sure that, m and p are not stored as, 0 or 1 in your calculator, because then it may check out, and then you may think it's going to check for all real numbers, where it may not check for all real numbers. It may just check because you use, such basic numbers, 0 and 1. Okay, so I'm going to store m and p as unique numbers. So there we go. I mean, those are the ones I chose. You could choose whatever you want. And then I'm just going to plug the left-hand side of the equation in the calculator, and then the right-hand side into the calculator, and just see if they equal. Okay, so here we go. There's the left-hand side, there's the right-hand side, and look, they're equal. So we know that the first rule checks out. So I'm going to pull a check mark next to that. All right, now let's do the same thing for rule 2 and for rule 3. Okay, so I did the second rule over here, right? I stored x and y as some unique numbers, and then I plugged in the left-hand side and the right-hand side, and you can see these do not match. So the second rule that they have here is not going to pan out for us. And then the third one I did down here, okay? I stored a and b, and here's the left-hand side of the equation, and here's the right-hand side of the equation. You could see that these match up. So the third rule is going to work for us. So if we look at the answer choices here, it looks like, which one says this? Choice 4, right? 1 and 3 can be proved. All right, now I'm going to do this by hand as well because, I mean, we actually, in this case, we didn't really prove it. We just did it in one example in the calculator. So I'm going to, do this algebraically so we could just make sure. Okay, so I'm going to start with the first one. So since this says m plus p squared, I just wrote out m plus p times m plus b. And I'm just going to double distribute. So when I do, I get m squared plus mp plus, I'm just going to write these alphabetically, mp plus p squared. And then if we combine our like terms, these combine to give us a 2mp. So if I bring down the m squared, and if I bring down the p squared, we can see that this, right here, matches up with the right-hand side of the equation. So, so the first rule looks good. Okay, now let's try the second one. All right, so since the second one says x plus y cubed, it means we have 3 x plus y is being multiplied together, so I wrote it out 3 times. It's when we double distribute. I'm gonna first just double distribute these two. So that'll leave us with x squared plus xy plus, again, I'm going to write that alphabetically, another xy, and then plus y squared. And here, if we combine our like terms, xy plus xy is 2xy. And we'll bring down the x squared, and we'll bring down the y squared. Okay, so that's what happens when we double distribute the first 2 sets of parentheses. Now let me take this x plus y, the third one, and just bring it down. Okay, so now what we have to do is we have to distribute this trinomial to this binomial. So I'm first going to take the x squared and distribute it to both terms. All right, so that'll give me x cubed, I'm just going to write it over here, plus x squared y. Okay, now let's distribute the 2xy to both terms. So 2xy times x would be 2, we have x times x, so that's x squared y. And then 2xy times y would be 2x y squared. Okay, so now let's distribute the y squared to both terms. So y squared times x is xy squared. We're just going to write everything alphabetically. And y squared times y is y cubed. Okay, now, if we combine our like terms, you should be able to see right away that it's not going to combine to give us this right here. I mean, we do have an x cubed, and we do have a y cubed, but these right here are not going to combine to give us 3xy. I'll combine and show you. So I'm going to bring down my x cubed, and then I can combine my x squared y with, where's the other one, right next to it, with the 2x squared y, so that'll give me 3x squared y. And then I can combine the 2xy squared with the xy squared to give me 3xy squared. And I can bring down the y cubed. So again, you'll see that this is not equivalent to the right-hand side, so that doesn't work. All right, now let's try choice 3. Okay, so with the third rule right here, I mean, I actually wrote out the left-hand side of the equation over here and the right-hand side of the equation over here. Because you can clearly see if you were to take this and write it out twice and double distribute, you're not going to be left with, terms in parentheses. So I think the easiest way is just to multiply this out, combine all your like terms, and see if both sides are equal. Okay, so since this has a square, I wrote it out twice. So let's just double distribute. So that gives us a to the 4th plus a squared b squared. Okay, and then we're going to distribute the b squared to both terms. So plus another a squared b squared. And then plus b to the 4th. Okay, remember when you're multiplying two terms with the same base, you add these exponents. All right, so now if we combine our like terms, we can combine these two terms in the middle. So 1 a squared b squared plus another 1 a squared b squared would be 2 a squared, b squared. And I'm going to bring down my a to the fourth. And I'm going to bring down my b to the fourth. So this is what we have on the left-hand side of the equation. Now let's see if the right-hand side is equal to it. We don't know yet, so I'm going to put a question mark. Okay, so let's double distribute. So that gives me a to the fourth minus a squared, b squared. And then minus another a squared, b squared. And then plus b to the fourth. Okay, now when I multiply these, this is just a monomial times a monomial, right? It's not like we're going to double distribute. There's not like, you know, with these we have subtraction signs in here. Here we just have one term times one term. So when we multiply these, we do 2 times 2 is 4, a times a is a squared, and b times b is b squared. So that'll be 4 a squared, b squared. Okay, so let's combine like terms. Now this a to the fourth doesn't combine with anything, so I'm just going to bring it down. Now the negative a squared, b squared, negative a squared, b squared, and this over here, the positive 4a squared, b squared. If we combine those, well, negative 1 minus 1 is negative 2, and negative 2 plus 4 is positive 2, so that gives us positive 2 a squared, b squared. And then I can bring down this b to the fourth because that doesn't combine with anything. And if you look, check this out, the left-hand side is equal to the right-hand side, so this does check out. Okay, so again, rule 1 and 3 work, so that would mean choice 4 is our answer. Okay, number 20, a researcher, I'm just going to underline some words here, randomly divides 50 bean plants into 2 groups. Okay, he puts one group by a window to receive natural light and the second group under artificial light. So it looks like one of the groups is the control group and the other group is the experimental group. They're, you know, assigning different roles to each group. He records the growth of the plants weekly. Which collection method is described in the situation? All right, this is totally a controlled experiment. When you randomly take a group of subjects and divide them into 2 groups and give one group one condition and another group the other condition, that's called a controlled experiment. Okay, number 21, they give us the graph of p of x, and they want to know what is the remainder when p of x is divided by x plus 4. Now, if we want to find what the remainder is when p of x is divided by x plus 4, we want to look at the value of the function at x equals negative 4. Okay, if we look at the height of the function or the value of the function at x equals negative 4, that'll give us the remainder. That's called the remainder theorem. So let's go to where x equals negative 4, and we can see right here the graph is crossing through the x-axis, so the y value here is 0. So what that means is the remainder would be 0. Okay, you're looking for what p of negative 4 is equal to, and p of negative 4 is equal to 0. Number 22, a payday loan company makes loans between $100 and $1,000 available to customers. Every 14 days, customers are charged 30% interest with compounding. In 2013, Remy took out a $300 payday loan. Which expression can be used to calculate the amount she would owe in dollars after 1 year if she did not make payments? Okay, well, what's happening here is we're going to be using our exponential growth formula because they're charged 30% interest, right? The account is growing. What they're going to owe is growing. So this is our exponential growth formula. But instead of just dividing by t like we normally do, here we're going to have to divide by the time that has passed divided by 14 because every 14 days customers are charged interest. So like if 14 days have passed, 14 divided by 14 is 1. One payment would have, one interest would be accumulated. If 28 days have passed, 28 divided by 14 is 2. 2 interest payments would have accumulated. Okay, so this is the formula we're going to follow. So basically, I'll just plug our numbers in. So A equals, so the amount that she borrowed was $300. So that'll be our P. And then 1 plus the rate. So 1 plus 30% would be 1.30. And then if she didn't make a payment for a full year, so in a year there's 365 days, so I'm going to plug that in for t, that's how many days have passed, and we'll divide that by 14 because every 14 days she's going to be charged interest. So that would be what, choice 4. 23, if x minus 1 is a factor of this given expression, what is the value of k? Now we know that if x minus 1 is a factor, it's going to divide evenly into it. Also, we know that if x minus 1 is a factor, then we know that x equals 1 will create this expression to be equal to 0. Okay, so let me just write that out. Okay, so in other words, what that means is if we take 1 and substitute it in for x into this expression, it should be equal to 0. So let's do that. Okay, so I just took all the x's and replaced them with 1's, and by doing so, I was able to set this equal to 0. So now let's just solve for k. Alright, so 1 cubed is equal to 1, and then minus, well, 1 squared is equal to 1, so negative k times 1 is just negative k, and then 2 times 1 is just 2. Alright, so I'm going to just add k to both sides. And when I combine my like terms on this side, 1 plus 2 is 3. Okay, so k equals 3, choice 3. Okay, number 24. Jake wants to buy a car and hopes to save at least $5,000 for a down payment. The table below summarizes the amount of money he plans to save each week. Based on this plan, which expression should he use to determine how much he has saved in n weeks? Okay, so first we have to kind of figure out what's going on from week to week. Now, if you look at these numbers here, right, to get from 2 to 5, well, I guess we're adding 3, but we're not adding 3 to 5 to get us to 12.5. So this is not arithmetic. All right, let's think about what we're multiplying by. 2 times what gives you 5? If you're not sure, you can always work backwards. You could do 5 divided by 2, and 5 divided by 2 is 2.5. So that means we're multiplying by 2.5 to get from 2 to 5. Now let's take 5 and multiply it by 2.5. If we do, it does get us 12.5. If we multiply this by 2.5, it gives us 31.25. So this right here is a geometric sequence, and we're multiplying by 2.5 to get from one term to the next. Okay, now since we want to know how much he has saved in n weeks, we're looking for the total amount that he has saved, so we're going to use our total formula. We're going to use our sum formula for a geometric series. Okay, so let's do this. So we're going to leave it as s sub n because we're not saying a specific number of weeks. For a sub 1, the first term is right here. It's 2. So we're going to replace the a sub 1's with 2's. Now the r is what we're multiplying by to get from one term to the next, which we said is 2.5. And we're going to leave this in terms of n. And on the bottom, it would be 1 minus 3, so 1 minus 2.5. So we just want to look and see which expression says this. It's actually choice 1 right here. All they did was they put the exponent on the inside of the parentheses rather than the outside, but we know that doesn't affect anything. So choice 1 is our answer. Number 25, the distance needed to stop a car after applying the brakes varies directly with the square of the car's speed. The table below shows the stopping distances for various speeds. Determine the average rate of change. Okay, I'm going to underline that. That's important. In braking distance in feet per mile per hour between one car traveling at 50 miles per hour and one traveling at 70 miles per hour. All right, so here's where 50 miles per hour is, and here's where 70 miles per hour is. Now, the average rate of change formula is really just the slope formula right here. It's change in y over change in x, okay? y2 minus y1 over x2 minus x1. So if we're looking at the speeds between 50 and 70 miles per hour, remember, this first row is our x's, so I'm just going to label this x1 and x2. And this second row right here is our y values. So I'm going to label this y1 and y2. So we're just going to plug it in the formula. Okay, so y2 would be 306.25, and y1 would be 156.25. And then x2 is 70, and x1 is 50. Alright, so if we subtract the numerators, that gives us 150. And if we subtract the denominators, that gives us 20. So when we divide those, we get 7.5. And the units would be feet per miles per hour. Okay? The units, I mean, first of all, they say it right here, feet per miles per hour. But since the numerators are y's, look, our y is feet. And since the denominators are x's, look, our x's are miles per hour. So that's where we get our units from. Okay, now, it says explain what this rate of change means as it relates to braking distance. Okay, so what this means is, I mean, the faster you're going, right, the more distance you're going to need to stop. So to put this into words, I would just say when traveling between the speeds of 50 and 70 miles per hour, an additional 7.5 feet is needed to stop for every mile per hour faster that the car is traveling. Okay, so again, when traveling between the speeds, I'm just going through the question, of 50 and 70 miles per hour, an additional 7.5, feet, we need that many more feet to stop for every mile per hour faster that the car is traveling. Number 26 wants us to determine the quotient and remainder when this is divided by this. Okay, and they're showing you to put it in this form. This is basically our quotient, our answer, plus our remainder over what we were dividing by. Okay, so we are dividing this expression, so that goes under the division bar, by 3a minus 2, so that goes outside the division bar. Okay, so this is how it works. You want to look at this 3a and say, what do I need to multiply this by to give me 6a cubed? So I need to multiply it by 2a squared. So I'm going to put a 2a squared on top here. And then I'm just going to distribute the 2a squared to both terms down here. So 2a squared times 3a would be 6a cubed. And then 2a squared times negative 2 would be negative 4a squared. Okay, now what we want to do is we want to subtract this binomial from these two terms. So to show we're subtracting, what we do is we change our sign and we circle it to show we're changing it, and we change this sign and circle it to show we changed it. Okay, so now let's combine our like terms. We know these first two terms are always going to cancel. And then 11a squared plus 4a squared would be 15a squared. Okay, so now since we have two terms out here, we need to have two terms down here. So what we're going to do is we're going to take this negative 4a and we're just going to bring it straight down. Okay, now start the process again. What do we multiply 3a by to give us 15a squared? Well, we multiply it by 5a. So I'm going to put a positive 5a up here. And then I'm going to take my 5a and distribute it to both terms. So 5a times 3a is 15a squared. And then 5a times negative 2 is negative 10a. And now again, we have to subtract this binomial from these two terms. So to show we're subtracting, we're going to change our sign and circle it, and change this sign and circle it. Okay, so your first two terms always cancel. If not, it means you made a mistake somewhere. And then combine negative 4a plus 10a is positive 6a. And we're going to bring down this minus 9. Okay, so then what do we multiply 3a by to give us 6a? Just 2. So I'm going to write plus 2. And then when we distribute, 2 times 3a is 6a. And then 2 times negative 2 is negative 4. Okay, so we're going to switch our sign and circle, switch our sign and circle. So these first two terms cancel off, and negative 9 plus 4 is negative 5. So this is our remainder. So we know we want to take our answer, and we want to take, since it's a negative remainder, I'm just going to put minus, and then we're going to put the remainder over what we were dividing by, which was the 3a minus 2. Okay, so this right here is our answer. Okay, so number 27 wants us to determine whether events A and B are independent or dependent. Okay, so we have two formulas for independence. The first one is just two events are independent if the probability of A given B equals the probability of A. And this makes sense because if they're independent, it doesn't matter if you're given B. That shouldn't affect the probability of A. All right, the second one, and this is the one I find that most of you use more often, is two events are independent if the probability of A and B equals the probability of A times the probability of B. So I'm going to use this one only because I find that most of you guys use this one. Okay, now let's take a look what they give us. They give us, if we were to use this formula, they give us the probability of A. They say right here that the probability of A is equal to 0.6, so I'm going to plug that in. Under the probability of A, we'll plug in a 0.6. I'm just going to put it in parentheses because we know here we're going to have to multiply it by the probability of B. They tell us the probability of B is 0.5, so let's replace the probability of B with 0.5. And unfortunately, we don't know this. We don't know the probability of A and B. Okay, this symbol means and. They give us the or, but they don't give us the and. So we're going to have to find the and when we do, we know that this side of the equation, 0.6 times 0.5, is equal to 0.30 or 0.3. So if we get the and to also be equal to 0.3, then that means this formula is going to check out. Okay, I think what I'm going to do, I mean, you can use the or formula, or you can make a Venn diagram, whichever way you prefer. The or formula, let me do it that way first. Okay, if you remember the or formula, you just add, subtract, the overlap. Okay, so they give us this. They give us the probability of A or B, right? They say right up here that's equal to 0.8. So I'm going to replace this with a 0.8. We know the probability of A, they told us is 0.6. The probability of B, they told us is 0.5. And we're looking for this component, okay? The probability of A and B. I mean, you could call that, if you want, you could call this X. You could make an equation, call this X and solve. I'm just going to leave it like that. So let's solve this equation. So if we add up 0.5 and 0.6 and 0.5, that gives us 1.1. So we have 0.8 equals 1.1 minus the probability of A and B. Now, I mean, you could just think about it logically. Like, if you have 1.1, what could you subtract from that to give you 0.8? Or think about this. What's 11 minus what gives you 8? 11 minus 3, right? So this has to be 0.3. Or if you want to, not think about it logically, you could just show all your work. That's totally fine as well. So if we subtract, we wind up with negative 0.3 equals negative the probability of A and B. I'm kind of running out of room, so I'm just going to kind of jump to the answer here. But if we divided both sides of this equation by negative 1, wouldn't that tell us that positive 0.3 equals positive the probability of A and B? Okay, so we know that the probability of A and B is 0.3. So guess what? If we plug it, if we go back to our formula over here and replace this with a 0.3, look at that. Both sides of the equation check out. So since they check out, we can write in words now that events A and B are independent because, and you would state this rule, because this is the rule we used. Okay, so there we go. So here's our rule stated out. Okay, you want to make your answer clear. Now, I know some of you guys don't really like to use this formula just because you don't have it memorized. It's a really easy formula to use if you have it memorized, but you could have used a Venn diagram. If you want to see it that way as well, I'll do it like that. If not, you can just kind of hit stop. Okay, so I made a Venn diagram. I set one up, and they tell us the probability of A is 0.6, so that goes on top of the circle, right? Not inside the circle. The probability of B is 0.5, so it means this whole circle the probability of getting this whole circle would be 0.5, so we'll put that on top. And then they tell us the OR is equivalent to 0.8. Now we know the OR is this number plus this number plus this number, right? The three numbers within the circles adds up to the OR. Okay, so if we want to find the AND, it's actually really easy to do. If you were to add up these two numbers on top, right, they would add up to more than 0.8. And the reason they would add up to more than 0.8 is because this middle number was accounted for within the 0.6 as well as the 0.5. It was accounted for twice. So if we want to figure out what number was accounted for twice, let's just add these two numbers on top. So 0.6, where can I fit that? Right here. 0.6 plus 0.5. And we'll subtract off what these three numbers within the circle should add up to. And when we do, that gives us 0.3. So that would be our overlap, and that is what we could put into this formula. Okay, so whether you want to do the Venn diagram or the OR formula, either way, you'll get the AND to be 0.3. And when we plug it in, we'll see that these events are independent because, and please state this, it fits into our rule. Okay, number 28 wants us, I'm just going to jump to it. It says state the exact probability that the student response is from a freshman given. Ooh, when we see that word given, we know that's where we're going to start. So I'm going to underline that word given, and this is where we're going to start the problem. So we're given that the student prefers to watch reality shows. So if this is the given category, we know we're only going to look at that column or that row. So if we're given they watch reality shows, here's reality shows, it's going to be the top of a column. So we're only going to look at this column. All right, so let me just kind of circle it. Now, within that column, we know how many were seniors and how many were freshmen, but we might as well total that up. And if we total that up, that gives us 213. Okay, so if that's the given category, we know if we want to find the probability, right, probability, we're going to have a numerator and a denominator. That is going to be the denominator. That's the total number of people that we're looking at in this given condition. Now, out of those 213 people, now we go back and read what comes before that in the sentence. How many of them are freshmen? Well, here they are. 103 out of the 213 are freshmen. So this is our answer. Now, if you prefer to use the formula, I actually found that most of you guys did better not using the formula with the table, but if you prefer to use the formula, I mean, that's what's good about math. You do it whichever way is easiest for you. We know the given formula is the probability of, and I'm just going to say F for freshman and R for reality. So the probability of freshman given reality is equal to, and let's use our formula, the given formula. The given formula states that that's equal to the probability of both events occurring, so the probability of F and R, and if you want to use a symbol for and, you can, over the probability of the given category, which is R. So let's think about this. When we look in the table, freshman and reality. Here's freshman and here's reality. If you follow freshman over to where reality meets, that's 103. And that's what we put on top of our fraction. And then the bottom is the probability of R. So we're actually really just finding the number of people who prefer reality shows. So the number of people who prefer reality shows here is 213. So that's in our denominator. Okay, so this really just follows the formula. Okay, so 29, they just want you to factor this expression. Now, you would factor this the same way as if this said 1x squared, okay? Since there's a 1 in front of our first term, we're just going to set up two sets of parentheses. And in this case, since x squared times x squared gives you x to the fourth, we're going to put an x squared in the first spot in each parenthesis. And we're just going to come up with two numbers that add to -4 and multiply to -12. So -6 and +2. And, you know, you want to look and say, can I factor further? If you have binomials, you want to say, do I have a difference of perfect squares? Now, this is a difference, but 6 is not a perfect square, so we can't factor this further. and this isn't a difference or, nor is 2 a perfect square. So this is actually factored completely, so this is your answer. If you wanted to check, it's really easy. One of two ways. You can, in your calculator, plug this in and hit enter, and then plug that in and hit enter and see if they match up, or just double distribute. X squared times x squared is x to the 4th, and I'll show this out. Okay, here's my check. So again, x squared times x squared is x to the 4th. X squared times 2 would be 2x squared. Negative 6 times x squared would be negative 6x squared. And when negative 6 times 2 is negative 12. And when we combine these like terms right here, they combine to give us a negative 4x squared. And I'll bring down my first term and bring down my last term. And look, this checks out. This says the same thing as our original statement. Number 30, it says, considering the middle 95% of the data, I'm just jumping down to the question, determine the margin of error to the nearest hundredth for the simulated results. And then they want us to explain what this value represents. Okay, now we know 2 different formulas for margin of error, right? We know this one. Margin of error is equal to 2 times the square root of p times q over n. And the other one we know is margin of error equals 2 standard deviations. Okay, so I'm actually going to use both formulas, and let's see what we get. So margin of error is equal to 2 times the square root. Now, P stands for the proportion of successes, okay, the proportion that we expect to occur. So here we could see that the proportion that we expect to occur is 0.35. Okay, 35% made in-app purchases. So that's going to be our P, 0.35. Now, Q is equal to 1 minus P. So 1 minus, sorry, these are supposed to be parentheses. 1 minus 0.35 would be 0.65. Okay, and then N just stands for your sample size, or the number of participants. So we could see here, ready? We did a random sample of 140 users. 140 is the number of people we were looking at here. So I'm going to divide this by 140. And when I plug that in my calculator, let's see, they want you to round to the nearest hundredth. I wind up getting 0.08. Now, even easier, I mean, if you look at this, this is the easier formula to use. Since we know the margin of error is equal to 2 standard deviations, look, they tell us what a standard deviation is equal to. So all we have to do is just 2 times that number. And when you multiply that out and round to the nearest hundredth, again, you get 0.08. So the margin of error is equal to 0.08. Okay, now they want us, it says in the given context, explain what this value represents. Now, in order to explain what this value represents, I mean, this tells you how far out you can go from the mean and still be, in an acceptable interval, in a reasonable interval. So since they're telling us to find the middle 95% of the data, let's find the 95% confidence interval, okay? So we know in order to do that, we do the mean plus and minus, either the margin of error or 2 standard deviations. I'll write them both out, but it's really the same thing. The mean plus and minus 2 standard deviations, or the mean plus and minus what we just found, the margin of error. Okay, so we know the mean, they give it to us right here, is 0.35. So we do 0.35 plus and minus 0.08. So let's see what our interval is here. If we do 0.35 minus 0.08, it gives us 0.27. And then I'm going to use my little through. If we do 0.35 plus 0.08, it gives us 0.43. So what this margin of error represents in the context of the problem is that basically anywhere between 27% and 43% of users are expected to make in-app purchases, because that's what that's talking about. Okay, so there we go. I just wrote it out. A margin of error of 0.08 represents that 27% through 43% of users are expected to make, that should say in-app purchases, not it-app purchases, are because the margin of error really tells us how far below and how far above the mean we can go in order for it to be considered like a normal, typical, usual occurrence. So number 31 gives us a recursive formula, and what they want us to do is they want us to state the first 4 terms in the sequence. Okay, so I put an answer box over here, so this is what we're going to find in the end. Now they give us the first term equals 3, so let's just fill that in, okay? A sub 1 equals 3. All right, now if we want to figure out what a sub 2 is, what I'm going to do is I'm going to take this formula they give us for a sub n, and I'm going to replace this n with a 2. So we can rewrite that as a sub 2. Now, if we replace this n with a 2, wherever you see an n, you want to replace it with a 2. So that'll be equal to 1 plus 2 times a sub 2 minus 1. Okay, well, 2 minus 1 is just 1. So really what we're doing is we're doing 1 plus 2 times a sub 1. So I'm going to write that out. Okay, so this is going to be equal to 1 plus 2. Now we know a sub 1 is equal to 3. So let's replace the a sub 1 with a 3. And then 1 plus 2 times 3 is just 7. So there's a sub 2. There's our second term. All right, let's do the same thing to find a sub 3. So if we want to find a sub 3, we're replacing this n with a 3. So if we replace that n with a 3, wherever we see an n, we're going to replace it with a 3. So this will say 1 plus 2 times a sub 3 minus 1. Okay, again, we're replacing this n with a 3. All right, well, since 3 minus 1 is 2, really what we're doing is we're finding 1 plus 2 times a sub 2, right? Because 3 minus 1 is 2. Okay, so that gives us 1 plus 2 times a sub 2 we found was equal to 7, so I'm going to replace this a sub 2 with a 7. And then 1 plus 2 times 7 is 15. All right, let's do the same thing once more for a sub 4. Okay, so I replace the n's with 4's. So since 4 minus 1 is equal to 3, this is really going to say 1 plus 2 times a sub 3. And since we know that a sub 3 is equal to 15, that's what we just found, we'll replace the a sub 3 with a 15. And 1 plus 2 times 15 is equal to 31. So there's the first 4 terms. Now we're not done though, because it says, can this sequence be represented using an explicit geometric formula? Okay, geometric means you multiply to get from one term to the next. Now, we can tell just by looking at this recursive formula that if it was geometric, a sub n would have to be equal to some number times a sub n minus 1, okay? Some number times the previous term. We can't have this 1 plus on there. All right, remember the recursive formula, you state the first term, and you say to find the nth term, you take the previous term and just multiply it by some number. You can't, have anything added or subtracted on here. So this is definitely not geometric. But even if you look at the answers, I mean, there's no consistent number that you're multiplying each of these by to get from one term to the next. Okay, so I just put it out in words right here. I just said, no, this sequence cannot be represented using an explicit geometric formula because there's no common ratio. There is no number that you can multiply by to get from each term to the next term, okay? So the answer to that is no. Number 32, the world population was 2,560 million people in 1950 and 3,040 million in 1960, and can be modeled by the function they give us there. All right, they tell us t is the time in years after 1950, and p of t is the population in millions. So what they want us to do here, they say they want us to determine the average rate of change on this interval between and including 4 and 8, and they want us to round our answer to the nearest hundredth. Okay, so here's our average rate of change formula. I mean, we're not actually using x's and y's in this example. We're using p of t and t. So the y values are represented by the p of t values, right? What we get when we plug in the t values here, and the x values are going to be represented by our t's. Okay, so let's start plugging in the numbers. So let me start actually with the denominator. So the t values are given to us right here. So we're going to take t2, which is 8, and subtract t1 from that, which is 4. So 8 minus 4. Now in the numerator, we want to take the y values, or in this case, the p of t values that correspond with each of these. So like if you want to take, if you want to figure out what y value or what p of t value corresponds when t equals 8, all you have to do is just take 8 and substitute it in for t into the right-hand side of this equation. Okay, so I just took 8 and substituted it in for t into the function. Now I'm going to take this 4 and substitute it in for t into that function. All right, so that's it. Okay, now we just have to figure out what this is equal to. I would use alpha y equals in my calculator and plug this in exactly like you see it. Okay, that way there's, it's rounded to exactly what it needs to be. So when I plug this in my calculator, I wind up getting 48.7815. So that would round to the nearest hundredth, right? That would round to 48.78. And my units would be right here, millions of people per year. So millions, or I'll just say 48.78 million people per year. Number 33 wants us to find algebraically the zeros of p of x, and then they want us to graph y equals p of x on the set of axes. Okay, so this isn't so bad. If we want to find the zeros, all you do is just take p of x and replace it with a 0. Okay, so let's solve. So we'll have 0 equals, now this, we're going to solve through factor by grouping, right? We can group together the first two terms and pull out an x squared, which leaves us with x plus 1. And out of the next two terms, let's pull out a negative 4, which also leaves us with a positive x and a positive 1. Okay, so I'll bring down the 0 equals, and now I'm going to take this x squared and the negative 4, and I'll group them together in one set of parentheses. And I will rewrite this common binomial that we see here once. Okay, so x plus 1 we write once. Now if we look here, I mean, you could make a t-chart at this point if you want, but I like to always factor further if we can. So if we see x squared minus 4, let's factor that further to x plus 2 times x minus 2. And then I'm bringing down the x plus 1, and now that everything is factored for us, completely factored, now we can make our t-chart. So we wind up getting x equals negative 2, x equals positive 2, and x equals negative 1. Okay, so these right here are our zeros. If you prefer to write it like this, usually you write them in ascending order. You can write it like this as well, but it totally doesn't matter. Either way is fine. Okay, so now what they want us to do is, it says on the set of axes below, graph y equals p of x. Okay, so I'm going to first plot the zeros that we know. So we have a 0 at negative 2, at negative 1, and at positive 2. And then, you can actually just, if you want, you could just plug this in your calculator, right? You can go to y equals, and you can plug this in and just copy the points down from the table of values. Okay, so there they are. So I'm going to just plot any point that, will fit onto this set of axes. So negative 3, negative 10, that'll fit. We already have negative 2, 0. We already have negative 1, 0. I can grab 0, negative 4. I'm just going down the list here. We can graph 1, negative 6. And then we already have 2, 0, and 3, 20. I'm not fitting on here. Now I can see that the graph is going to look something, right? It's going to kind of come up, go down, and go back up. I'm not exactly sure how high it's going to go up right here. So you know what I'm doing on my calculator right now? I'm going to second trace. That brings me to calc. And I'm going to go to choice 4, which is maximum. And I'm going to put kind of a left bound and a right bound around my maximum because I want to see, does this go higher than 1? Is it lower than 1? I want my graph to look good, right? So let me do this in my calculator. Okay, and it's showing that the maximum occurs at negative 1.5.9. So it's going to be somewhere right around here. So I don't want my graph to go above a height of 1. My dots are huge. But anyway, when we go to connect it, it's going to look something like that. And we could put arrows because it continues on, and we'll label it. You could just label it P of X if you want, or you could put the entire equation on there. 34. Carla wants to start a college fund for her daughter, Leela. She puts $63,000 into an account that grows at a rate of 2.55% per year compounded monthly. Okay, I'm going to stop right there. Because we see this compounded monthly, we know we're going to need to use our compound interest formula. Now, okay, so this is our compound interest formula, and we're just going to need to adjust it to fit the variables used in the problem. So it says, write a function c of t. So instead of a, we're going to have c of t. Now we know the p stands for the initial. So 63,000 is what was initially put into the account, and then it'll be 1 plus. Now the rate is 2.55%. So we know we need to move the decimal place over 2 places to the left. So that becomes 0.0255. And we want to divide that by n. Since we're compounding monthly, okay, there's 12 months in a year. Okay, there's months as compared to years. There's 12 months in a year. So what we're going to do is we're going to replace the n with 12. It's the number of months that fit into a year. Now, we're also going to replace this n right here with a 12, and we want to leave this in terms of t. Okay, we want to create a function where if, we want to figure out how much is going to be in there after 10 years, we could replace the t with a 10. After 20 years, we could replace the t with a 20. Okay, so the second part wants us to calculate algebraically, so not graphically, the number of years it will take for the account to reach $100,000 to the nearest hundredth of a year. I'm just going to circle what's around to. Okay, so we want to know when is c of t going to reach $100,000. So let's replace that with $100,000. Okay, so this is what we're solving. So the first thing I'm going to do is I'm going to divide both sides of the equation by 6,300. I'm trying to get that parenthesis being raised to the 12t power by itself. Okay, I'm just going to simplify this, right? These 3 zeros on top cancel off with the 3 zeros on bottom. So I'm going to leave this as 100 over 63. I mean, you could plug that in your calculator, but it's going to give you a decimal that keeps going. So why not in the middle of the problem have the exact value? So 100 divided by 63. And if you plug this into your calculator, it does give you a decimal that terminates, that stops. So if you want to write the parenthesis as, let's see, we get 1.002125. And we can make that to the 12t power. Okay, or you could have just left it as is. It doesn't matter. Now, when your exponent contains the variable, what we do is we put the word log in front of both sides of the equation. And the reason we do that is because the power rule tells us we can take this exponent right here and we can bring it to the front of the word log. Okay, so I basically just rewrote, I just brought this down. And I brought this down, and I brought the 12t up in front. And by the way, if you want to put this in parentheses, you can. Okay, so we're trying to get the t by itself. So I'm going to first divide both sides by log of 1.002125. Okay, now at this point, when I'm going to plug the left-hand side of the equation into my calculator, and I am going to round on my paper, but I'm going to leave this, whatever I get when I plug this in my calculator, I'm going to leave that decimal in my calculator. Okay, so in my calculator, I see a big long decimal that keeps going, but on my paper, I'm just going to write 217 point, and I usually like to round to 4 decimal places on the paper. And on the right-hand side of the equation, we're just going to bring down the 12t. So now we're going to divide that number that's in the calculator by 12, And when we do, we get approximately 18.1383. And they want to know how long will it take for the account to reach $100,000 to the nearest hundredth. Okay, so we're going to round this. Luckily, it rounds up, but in order for it to reach it, we would have to round up either way. It's going to take 18.14 years for it to reach $100,000. All right, so there we go. Okay, so number 35 wants you to solve the following system of equations algebraically. Now, even though we're going to do it algebraically, remember the first thing we do is we do this in our calculator, and the calculator gives us the answers. That way, when we do it algebraically, we know if we're on the right track or not. Okay, so here's the steps in the calculator. So first thing we're going to do is in our calculator, we're going to go to second x inverse, because you can see it says matrix on top. You're going to scroll over to edit, and you're going to create a 3 by 4 matrix. Okay, so basically this is how you set it up. You want to make sure, at first this will say 1 by 1. You want to set this to 3 by 4 because we have 3 rows and 1, 2, 3, 4 columns. And then you just basically insert the numbers from each equation into each row. So see how we have a 2, then a 3, then a -4, then a -1? I typed in 2, 3, -4, and you can't see it over here because the screen doesn't fit it, but I typed the -1 over here. Okay, you just go through. So 1, -2, 5, 3, 1, -2, 5, and then there's a 3 over here, and so on. Okay, now step 2 says to go to a home screen. So you're going to clear out of there. You're going to go to second, quit. All right, so now you have a blank screen on your calculator. Now you're going to go back to matrix, so second x inverse, so it's going to bring you to matrix. You're going to go over to math, and you're going to go down all the way till you see letter B. It says RREF, reduced row echelon form. Okay, don't pick REF, it should say RREF. All right, from there you're going to go back into matrix for the third time, and you're going to hit enter on matrix A. And then what you want to do is you want to hit enter again, and this is what you will see. Okay, so this right here, this last column gives us our answers. It tells us that if we have 1x, it's equal to -2, 1y is equal to 5, and 1z is equal to 3. So let's just make an answer box that says that. Okay, so as we do the problem, we know that these are the answers we should be getting. Okay, -2, 5, and 3. -2, 5, and 3. Okay, so now it's time to start doing it algebraically. Now, if you remember, the first thing we do is we label our equations A, B, and C. That way, whoever is grading your paper knows which equation you're using when. Okay, and then we label our steps. So step number 1. Now, in step number 1, we want to line up 2 of the equations. It doesn't matter which 2, but you want to line up 2 equations, and you want to try to eliminate one of the variables. Now, if you look at the equations here, to me, I think it's actually the easiest to try to eliminate the x's. So I'm going to first start off lining up equation A and C, because think about it. C has a -4x. If we multiply this equation A by 2, then 2 times 2x is 4x. Wouldn't a positive 4x and a negative 4x cancel out? Okay, so I'm going to do 2 times equation A, and I'm going to add to that equation C. Okay, now if I take equation A and multiply everything by 2, so 2 times 2x is 4x. 2 times 3y is 6y. 2 times -4z is -8z. And then 2 times -1 is -2. Now here it just says I'm taking equation C and just copying it down, right? There's no number in front of it. So I'm going to take this equation and copy it down. So -4x plus y plus z equals 16. Okay, so now let's add these up. So the 4x and the -4x are going to cancel, right? And that's exactly what we wanted to happen. All right, and then when we combine 6y plus y, that's going to give us 7y. -8z plus c is -7z. And then -2 plus 16 is 14. So now we created a new equation here. So when we create an equation, we want to label it. So I'm going to label this one D. Just go alphabetically, right in order. Okay, so now step 2. Now with step 2, we want to go back to our original equations, and we want to again try to eliminate the same variable that we did in step 1. So we're going to try to eliminate the x's. Now we've already used equation A and C, so now we have to pick a different pair of equations. So I'm going to just use A and B. This says 2x. If I could make this say negative 2x, then the x's would cancel. So in order to do that, we're going to multiply equation B by negative 2. All right, so we're using equation A, and we're doing negative 2 times B. All right, so equation A, we're just going to copy it down. So it says 2x plus 3y minus 4z equals negative 1. Now here we're going to take negative 2 and distribute it to all 3 terms in equation B. So negative 2 times x is negative 2x. Negative 2 times negative 2y is positive 4y. Negative 2 times 5z would be negative 10z. And then negative 2 times 3 is negative 6. Okay, don't forget to multiply to the other side of the equation as well. All right, so let's add them up. So the x's cancel. 3y plus 4y is 7y. Negative 4z and negative 10z is negative 14z. And negative 1 minus 6 is negative 7. And since we created a new equation here, we're going to call that equation E. I mean, you can call it whatever you want, but I like to go right alphabetically. Okay, so now what happens is, now we look at equation D and we look at equation E. And we want to line them up and try to get something to cancel out. Now, this is a positive 7y and this is a positive 7y. So if we multiply one of them by a negative 1, then we'll have a negative 7y and it'll cancel off. All right, so what I'm going to do is, let's see, step 3. Let's see if I can fit it here. Step 3. So I'm going to line up equation D, which says 7y minus 7z equals 14. And I'm going to do negative 1 times E. So I'm going to distribute a negative to each of these terms in E. So this will become negative, right? Negative 1 times 7y is negative 7y. If I distribute the negative 1 to the negative 14z, it'll become positive 14z. And if I distribute the negative 1 to the negative 7, it becomes positive 7. All right, so now if we add these up, the y's cancel off. Negative 7z and a positive 14z combine to give us positive 7z. And then 14 plus 7 is 21. So now we could solve for z. If we divide both sides by 7, we wind up getting z equals 21 divided by 7 is 3. So we get z equals 3. So what's nice about doing the calculator first is, look, we know that we're on the right track, so we're going to keep going. If we didn't get the same answer that our calculator gave us, we'd want to stop here and try to find our mistake. Or look back on the calculator. Maybe you made a mistake in the calculator. Okay, so now we're on to step 4. So step 4. Now, once you solve for one of the variables, right, so we solve for z, we can go back to either equation, E or D, and we can plug in the 3 for z. I'm going to use equation D, and that way I'll be able to solve for y. So I'm going to use equation D. I'm going to write it out. It says 7y minus 7z equals 14. And since we know that z is equal to 3, I'm going to just replace this z with the 3 that it's equal to. And then this is what we'll solve. All right, so 7y minus 7 times 3 is 21 equals 14. And if we add 21 to both sides of the equation, that gives us 7y equals 35. And divide by 7, we get y equals 5. And look at this. We are still getting the same answer, so that's good. All right, step 5. Let's hope we get x equals negative 2. Now, with step 5, you can go back to any one of the 3 original equations. It doesn't matter because, I mean, we already know 2 of the variables, so now we could solve for the third. Okay, so I'm going to go back to equation B, because if we're solving for x, that's x is by itself, so that's an easy one. So we're going to, let me write it out first. It says x, using equation B, it says x minus 2y plus 5z equals 3. Okay, so x minus 2 times, we know y is equal to 5, we just found that out. And then plus 5 times, we know z is equal to 3. Okay, so we have x, now negative 2 times 5 is negative 10, and positive 5 times 3 is positive 15. And if we combine the negative 10 and the positive 15, that gives us positive 5. So we have x plus 5 equals 3. And then if we subtract 5 from each side of the equation, look at this, we wind up with x equals negative 2, which matches up with what we have up here. All right, so number 36 has 2 parts to it. The first part says the height, h of t in centimeters, of a piston is given by this equation, where t represents the number of seconds since the measurement began. Determine the average rate of change, all right, so this is what it's asking us to do, in centimeters per second of the piston's height on the interval where t is between 1 and 2, including those 2 values. All right, so that's the first thing we have to do, determine the average rate of change. Okay, so here's our average rate of change from, it's just the slope formula. The only thing is with our equations, we are, instead of using x's and y's, we're using, in place of x, we're using t, right? Time refers to your x values. So technically, I mean, you don't have to write this if you don't want, but technically we're doing t sub 2 minus t sub 1. And then in place of y's, we're using h of t. So we're doing, I can also write that as h of t sub 2 minus h of t sub 1. Okay, so our t values are given to us right here. So t sub 1 is 1, and t sub 2 is 2. So I'm going to replace this with 2 minus 1. Okay, now h of t, right, it wants me to take my t value, so my t value is 2. It wants me to find h of 2. Now h of 2 would be equal to this right here, where I'm replacing the t with a 2. Okay, so again, I just took this function and replaced the t with a 2, okay, because we have a 2 in the t spot. Now we want to take the same function, and this time t is equal to 1. So we want to replace the t right here with a 1, and we're going to subtract that from this. Okay, let me actually, I'm going to group this whole thing in a parenthesis, because we kind of have a lot going on here, and we want to subtract from that. I'm going to put this whole big thing in a parenthesis. We're going to subtract what we get when we replace this time the t with a 1. Okay, so again, all we really did here was the slope formula. We did y minus y over x minus x. So h of 2 minus h of 1 over 2 minus 1. And to be honest, the reason why I write this whole thing out like this, I think it's a good idea to use alpha y equals and plug it in your calculator exactly like you see it. If you're someone that likes to do it in parts, you can do that if you want. I mean, if you plug this into your calculator, it winds up giving you 2. And then I'm going to take this minus sign down. And if you wind up plugging this into your calculator, it winds up giving you 14. And we know 2 minus 1 is just 1. So that leaves us with negative 12 over 1, which is negative 12. And then the units there would be centimeters per second. Okay, so the average rate of change is negative 12 centimeters per second. All right, so the second part of the question says, at what values of t to the nearest tenth of a second does h of t equal 0 in the interval where t is between 1 and 5? And they want you to justify your answer. Now, if you notice, they don't say to do it algebraically. And that's because, you know, based on what we're learning this year in Algebra 2, they're pretty much expecting you to do this graphically. So I think the first thing we have to do is let's graph h of t in our calculator. Okay, so this is what our graph looks like. And it does say they only want you to look on it on the interval from 1 to 5. So here's where 1 is. and there's where 5 is. So we're really only looking at this portion of the graph. If you notice, some of the graph gets kind of cut off, which it doesn't really matter. I mean, if you want to adjust your window to fit, you know, if you want to adjust the window to fit what we're looking at here, you could adjust your window so that the x min is 1 and the x max is 5, so 1 to 5. And then for the y values, we know the minimum is the vertical shift minus the amp. So 8 minus 12 is -4. And the max is the vertical shift plus the amp. So 8 plus 12 is 20. So here this is going from 1 to 5 and from -4 to 20. And you'll see the graph. Okay, so really it's just kind of zooming in on this portion right here of the graph. It doesn't matter which way you look at it. What they want to know is they want to know at what values does h of t equals 0. So when does the height equal 0? All right, well, we know it equals 0 right here. Here, I'll do this. Where the graph crosses, or if we're looking at this one here and here, where the graph crosses the x-axis, okay, because this is where the y values aren't positive or negative. They're at 0. All right, so if we want to find those, our calculator does it for us. You're going to go to second trace, and you're going to choose choice 2, which says 0. Okay, so then when we do that, I'm just going to guide you through the process. It makes you put a left bound and a right bound around each of these zeros. So I'm first going to take a look at this 0, okay? Okay, so it asks you to make a left bound. So if we're looking at this 0 right here, just move your cursor so it's somewhere to the left, right, to the left of this point. It's left and above it. And then hit enter. Then it'll say right bound. So you're going to take that cursor and you're going to move it until we get to the right. See right here, to the right of this 0. Okay, see how that's to the right of it? And hit enter. It'll take a guess and hit enter again. And then you can see in this diagram, this is telling us our 0 is at 2 point, and they want us to round to the nearest tenth, so 2.2. Okay, y is 0 when x is 2.2. Okay, so at 2.2 seconds, the piston's height is at 0, so that's one of them. Now, if you notice, in the interval between 1 and 5, is that where 5 is? 1, 2, 3, 4, 5. There's another 0 right here. So let's repeat the process. Go back in your calculator to second trace, and you're going to choose choice 2, which says 0. Okay, so this time I wanted to go to the left of this point, this 0. Okay, so if this is where the 0 is, I want to go to the left of it, but be careful, don't go too far to the left, because if you're over here, then aren't we to the left of this 0 as well? You want to make sure you're just to the left of this 1, 0. So there I am. And then I hit enter. Okay, now it says right bound, so I want to move to the right of that 0. I don't want to go too far to the right that I'm to the right of other zeros as well. So once I get to the right of it, right there, just hit enter. Hit enter again, and we'll see this one occurs when x equals 3.8. So we're not using x's here, right? We're using t. So at 3.8 seconds, that's another time within the interval between and including 1 through 5 that the piston's height is 0. Okay, number 37. Website popularity ratings are often determined using models that incorporate the number of visits per week a website receives. One model for ranking websites is P of X right here, where X is the number of visits per week in thousands. Let me underline that. It's probably important. And P of X is the website's popularity rating. Okay, according to this model, if a website is visited 16,000 times in 1 week, what is its popularity rating rounded to the nearest tenth? All right, well, P of X is what gives us the popularity rating. So what we're going to do is, if we want to figure out if it's visited 16,000 times, right? X is the number of visits per week in thousands. So instead of plugging in 16,000, I'm just going to plug in 16 because this is already in thousands. So we're going to find P of 16. Okay, and if I replace this x with a 16, I'm going to replace that x with a 16. So we'll have P of 16 equals log of 16 minus 4. So this is actually pretty straightforward. All you have to do is just plug this log of 16 minus 4 or log of 12 in your calculator and just round to the nearest tenth. All right, so we wind up getting 1.1. All right, so the first part of this question is done. That was pretty straightforward. Now the next part says to graph P of X on the axes below. Okay, so I'm just gonna, in my calculator, I'm just gonna go to y equals and plug in log of x minus 4. Okay, so if you look in the table of values, what you'll notice is any x value, I guess that's less than 5, gives us an error. Well, any rational x value. So anything x less than or equal to 4 gives us an error. So we're going to start graphing this at 5. Okay, so at 5, 0, now if this is where 4 is and this is where 6 is, 5 would be right in between them, so right there. So at 5, 0, you're going to put a point. At 6, you're going to estimate where 0.30 whatever would be. So if this is 0.25, figure 0.30 would be like right there, and you're going to put a point and you're going to graph all of these points. Now, you can either put an arrow on the graph, or if you have your graph go all the way to the end of the graph, as long as you go all the way to the end, it's implied that it's going to keep going, so you don't have to put an arrow. But I always say put one on because it doesn't hurt. Okay, so you can graph that, and then we're going to go down to the part below. Okay, so it says an alternative rating model is represented by R of x, where x is the number of visits per week in thousands. So again, x is representing the number of visits per week in thousands. They want us to graph R of x on the same set of axes. So you can just go to y2 in your calculator and plug in 1/2 x minus 6, and go to the table of values and just copy those points, just plot them on the set of axes above. Okay, so this is what my graph looks like. I mean, I didn't put arrows because, like I said before, as long as you go to the end of the graph, it's implied that there's arrows. If you want to put arrows, though, you could, but please only put it on the right-hand side of your function where x approaches, infinity, because the graph can keep going this way, but we're not gonna have a negative popularity rating, so we can't go down this way. Okay, it says, for what number of weekly visits will the two models provide the same rating? So basically they're asking us, where do these intersect? So you can see right here, they intersect at 14. Now, this is in thousands, so when you state your answer, you want to say 14,000 and then visits. If you want to double check, if you still have this equation in y1 and this equation in y2, you can go to second trace intersect, or even easier, if it occurs at exactly 14,000, you can just go to your table of values and see if the y values are the same. Okay, so just for a double check, you could see when x equals 14, which really means 14,000, both of the y values are 1. Okay, the popularity rating is 1. They're the same.